Around 100 million years ago, while dinosaurs thundered across the land, the ocean was a very different place. Sea levels worldwide were dramatically higher than they are today, flooding vast stretches of the continents and creating enormous shallow inland seas. The global climate was warmer than anything we experience now, with no polar ice caps and ocean surface temperatures reaching as high as 35 to 40 degrees Celsius in the tropics. The atmosphere was rich in carbon dioxide, and the world's coastlines looked nothing like the ones we know, with entire continents sitting in different positions and large landmasses submerged beneath warm, shallow water. One of the most extraordinary of these ancient seas was the Western Interior Seaway, a vast body of warm, shallow water that stretched directly through the center of what is now the United States and Canada, running over 3,200 kilometers from the Gulf of Mexico all the way to the Arctic Ocean. At its widest, it spanned nearly 1,000 kilometers, splitting the North American continent into two separate landmasses. Where the flat prairies of Kansas and South Dakota exist today, there was once a warm tropical sea teeming with life. The white chalk cliffs that still rise above the Great Plains of western Kansas are in fact the compressed remains of billions of microscopic sea creatures that once lived in that vanished ocean, now turned to stone over tens of millions of years. This was not a quiet or peaceful ocean. It was dense with life at every level, from the microscopic plankton drifting in the sunlit surface waters all the way up to the enormous predators that patrolled the depths. And at the very top of that food chain lived some of the most extraordinary animals ever to inhabit the seas, creatures that had made one of the most remarkable evolutionary transformations in the history of life on Earth. If you were to find yourself swimming in the Western Interior Seaway 85 million years ago, the first thing you would notice is the warmth. The water would feel more like a bath than an ocean, hovering somewhere around 28 to 30 degrees Celsius, even far below the surface. Looking around you, the water would be surprisingly clear, lit by a strong tropical sun filtering down through the upper layers. But you would not have long to admire the view, because the ocean around you would be anything but safe. Directly below you, drifting in slow spirals, you would see hundreds of ammonites. These were coiled, shelled cephalopods related to modern squid and octopus, and they were among the most abundant animals in the Cretaceous Ocean. Some were the size of a dinner plate, while others grew to over 2 meters in diameter, their beautiful spiral shells ranging from tight coils to loose, unraveling shapes. They were everywhere in the Cretaceous seas, filling the water column in numbers comparable to modern fish shoals. Looking toward the surface, you might catch sight of something plunging into the water from above. This is Hesperornis, a large, flightless diving bird that lived alongside the MOSASAURS in the Western Interior Seaway. Unlike modern birds, Hesperornis had almost no functional wings at all, having sacrificed flight entirely for swimming ability. It was built more like a penguin than any modern flying bird, with powerful legs set far back on its body that drove it through the water at impressive speeds. Hesperornis could reach up to 1.8 meters in length, nearly 6 feet, making it one of the largest birds of its era. It hunted fish by diving from the surface, chasing them down in the same way modern diving birds do today. Sharing the water with Hesperornis were the plesiosaurs, long-necked marine reptiles that had been in the ocean long before the mosasaurs arrived. The elasmosaurs were among the most recognizable, with necks so long they accounted for more than half their total body length. A large elasmosaur could reach 14 meters from head to tail, roughly the length of a city bus, with a neck alone stretching to around 7 meters. They moved through the water on 4 broad, paddle-like flippers, using slow but powerful strokes to propel themselves forward. Scientists believe they fed on fish and squid, using their extraordinarily long necks to strike at prey from an unexpected angle. But lurking in the same waters was something else entirely. Something that had not been in the ocean before the Cretaceous period. And to understand where it came from, we need to go back slightly further in time. Around 98 million years ago, small lizards were hunting along the warm, humid coastlines of what is now Texas. These creatures, known as Dinosaurs, looked much like modern monitor lizards and measured roughly 1.5 meters in length. They had functional legs, they probably laid eggs on land or nearby, and in most respects, they were perfectly ordinary coastal reptiles. But they had developed a habit of hunting in shallow water, chasing fish along the shoreline and in river mouths, and that habit would set in motion one of the most dramatic evolutionary transformations in the history of the planet. One of the earliest known transitional animals in this lineage is Dilophosaurus turneri, named after the city near Dallas, Texas, where its fossils were found. Dilophosaurus was less than 1 meter long and still had fully functional weight-bearing limbs. But its snout was already elongated and narrow in the style of a water hunter, and its body showed early signs of the streamlining that would define its descendants. In Dilophosaurus, you can see the starting point of the entire mosasaur story, a small shoreline lizard standing at the edge of the ocean with 30 million years of evolution ahead of it. What accelerated that evolution was a catastrophe. Around 92 million years ago, a major extinction event caused by volcanic activity on the ocean floor devastated marine ecosystems worldwide. The ichthyosaurs, dolphin-shaped marine reptiles that had dominated the seas for over 150 million years, disappeared entirely. The pliosaurs, which were large-headed, powerful ocean predators, vanished alongside them. These extinctions left an enormous ecological gap at the top of the marine food chain, and the descendants of Dilophosaurus rushed to fill it. Within roughly 25 million years, they had become the dominant predators in every ocean on Earth, evolving into dozens of different species adapted to every environment and feeding strategy the ocean could offer. These animals were the mosasaurs. The word mosasaur comes from the Latin name for the Meuse River in the Netherlands, near where the first fossils were discovered, combined with the Greek word for lizard. They were not dinosaurs. They were marine lizards, members of the same broad group that includes modern monitor lizards and snakes, and they had transformed themselves into something that looked far more like a giant eel crossed with a crocodile than anything we would recognize as a lizard today. Their legs had become broad, paddle-like flippers. Their tails had flattened into vertical propulsive fins, similar in function to a shark's tail. Their bodies had elongated and streamlined, and their skulls had grown into long, powerful weapons lined with rows of sharp, curved teeth. One of the most well-studied mosasaurs is Platecarpus, a medium-sized species that was one of the dominant predators in the western interior seaway around 85 to 75 million years ago. Platecarpus averaged around 4 to 6 meters in length, roughly the size of a large saltwater crocodile, and was built for speed and agility rather than brute force. Its body was relatively slender, its flippers wide and hydrodynamic, and its tail ended in a crescent-shaped fin similar to a modern shark's tail, allowing it to generate strong propulsion with each sweep. It was a pursuit predator, chasing fish and squid through the open water rather than ambushing them from cover. What makes Platecarpus particularly significant to scientists is one extraordinary fossil specimen found in the Niobrara chalk of Kansas that preserved not just bones, but traces of soft tissue. Examination of this fossil revealed that the internal organ arrangement of Platecarpus had more in common with modern dolphins and whales than with any land lizard. The kidneys were positioned farther forward in the body than in terrestrial lizards, matching the arrangement seen in marine mammals. The lungs ran parallel to each other in the way they do in cetaceans, rather than branching apart as in land-dwelling reptiles. This was an animal that had been so thoroughly redesigned by evolution for life in the ocean that its internal anatomy had converged with that of animals whose ancestors would not even begin returning to the sea for another 80 million years. While plate carpus was chasing fast-moving prey through open water, another mosasaur was taking a very different approach in the deeper, darker waters closer to the seafloor. This was Globidens, one of the strangest and most specialized mosasaurs ever discovered. The name means globe teeth, and that name tells you almost everything you need to know about what made this animal unusual. Where every other mosasaur had sharp, pointed, or blade-like teeth designed for gripping and cutting, Globidens had teeth that were completely round and smooth, wide bulbous crowns like polished river stones arranged in rows along its jaws. Globidens reached around 6 meters in length and was built less for speed than for power. Its skull was shorter and more heavily built than most mosasaurs, with jaw muscles of exceptional strength anchored to a broad, robust cranium. Those rounded teeth were designed for one purpose only: crushing the hard shells of ammonites, clams, crustaceans, and possibly sea turtles that no other predator in the ecosystem could efficiently break open. Scientists have found fossilized ammonite shells with the distinctive hemispherical bite marks of Globidens pressed into them, confirming exactly what those strange teeth were for. Globidens had large eyes to gather dim light in the deeper water where it hunted, and dense bones to help it stay submerged without expending energy fighting its own buoyancy. It occupied a niche that no other mosasaur was exploiting, and it filled that niche so effectively that variants of the shell-crushing mosasaur body plan appeared on multiple continents. If Globidens was the specialist, Tylosaurus was the tyrant. Living in the western interior seaway between roughly 85 and 80 million years ago, Tylosaurus was one of the largest and most powerful predators ever to inhabit the seaway, reaching lengths of up to 12 to 14 meters, which is comparable to a full-size city bus. Its name means knob lizard, referring to its distinctive blunt rostrum, a rounded projection at the tip of its snout that extended forward beyond the teeth like the prow of a ship. Scientists are still debating what this structure was for, with current theories suggesting it may have been used to ram and stun prey, to intimidate rivals, or possibly both. Tylosaurus had a body built for power rather than sustained speed, with a large, muscular trunk and a long, deep tail that provided enormous propulsive force in short bursts. Its skull alone could exceed 1 meter in length, and its jaws were lined with thick, slightly curved teeth designed for seizing and holding large prey rather than slicing. Like all mosasaurs, Tylosaurus also had a second set of smaller teeth on the roof of its mouth, the pterygoid teeth, which worked like a ratchet to draw struggling prey deeper into the throat. And like all mosasaurs, Tylosaurus was warm-blooded, maintaining an internal body temperature significantly higher than the surrounding ocean water and giving it a level of sustained activity and metabolic efficiency that cold-blooded animals simply could not match. Analysis of its bones suggests Tylosaurus maintained a body temperature of around 34 degrees Celsius, far above the ocean temperatures of its time. One exceptionally preserved Tylosaurus skeleton found in South Dakota tells us exactly what this animal was eating. Within the rib cage of the fossil, paleontologists found the remains of 4 separate animals: the bones of a Hesperornis diving bird, the bones of a large fish, what appears to be a shark, and the partial skeleton of a smaller mosasaur named Clydastes, a single stomach contents deposit containing 4 completely different victims from 4 different parts of the food chain. Tylosaurus was not a selective hunter. It was a comprehensive one, eating fish, sharks, diving birds, sea turtles, other marine reptiles, and apparently other mosasaurs without any particular preference. But Tylosaurus was not the only giant in these waters. Arriving later in the Cretaceous, roughly 82 to 66 million years ago, was the animal whose fossils launched the entire field of vertebrate paleontology, the animal whose skull sat in a Dutch quarry for years before anyone could agree on what it was, the animal that would eventually be named Mosasaurus hoffmanni. Mosasaurus hoffmanni was the largest confirmed mosasaur species and one of the largest marine predators in Earth's history. Current best estimates based on the most complete specimens place large individuals at around 11 to 14 meters in length, with a body mass approaching 4 metric tons, heavier than a full-grown African elephant. Its skull was immense, over 1 meter long, with robust jaws bearing dozens of heavy, slightly curved teeth, and a bite force estimated between 8,692 and 10,451 newtons, roughly comparable to the largest living crocodilians, but deployed from a far larger and more mobile skull. Chemical analysis of multiple Mosasaurus fossils confirms it occupied the highest trophic position of any animal in the late Cretaceous ocean, meaning it sat at the absolute top of the food chain, above sharks, above sea turtles, above every other mosasaur. Its diet appears to have included virtually everything. Fossilized bite marks on the shells of giant sea turtles show the broad, powerful marks of Mosasaurus teeth. Shark teeth have been found embedded in mosasaur bones, suggesting that even the ocean's sharks were not safe from these animals. One Mosasaurus fossil found in Angola contained the remains of 3 other mosasaurs inside its stomach, one of them the same species as the predator itself, which is the first documented evidence of cannibalism in the mosasaur family. There is also evidence suggesting Mosasaurus may have taught its young to hunt, based on a fossilized nautiloid shell that preserves bite marks from both a juvenile and an adult mosasaur of the same species, positioned as though the smaller animal was learning from the larger one. By 70 million years ago, the Mosasaur empire was truly global. Their fossils have been found in Belgium, Denmark, Russia, Turkey, Morocco, Angola, South Africa, Brazil, Argentina, New Zealand, and Antarctica. The chalk formations of western Kansas preserve the bones of animals that once hunted through tropical water in an ocean that no longer exists. Mosasaur fossils from Antarctica confirm that these warm-blooded animals were capable of maintaining their body temperature even in near-polar waters where cold-blooded animals would have been unable to function. A study published in 2025 presented evidence of a large mosasaur approximately 11 meters in length that appears to have lived primarily in freshwater rivers rather than the open ocean, suggesting the mosasaurs had even begun expanding into freshwater environments in the final millions of years before their extinction. The first mosasaur fossils known to science were discovered in 1764 in a limestone quarry carved into the hillside of Mount St. Peter, near the Dutch city of Maastricht in the Netherlands. Workers chipping away at the pale, chalky rock found a massive fossilized skull unlike anything that had been seen before, with long jaws lined with large curved teeth. For years, nobody could agree on what it was. Some scientists argued it was a giant fish, others insisted it was a crocodile, and the prominent Dutch naturalist Petrus Camper concluded in 1786 that it belonged to a whale. A second skull was found in the same quarry sometime between 1770 and 1774, and this specimen became so celebrated in scientific circles across Europe that when the French Revolutionary Army marched into Maastricht in 1794, orders were reportedly given to seize it. According to the legend that has surrounded this story for over 2 centuries, the skull was hidden and eventually surrendered in exchange for 600 bottles of wine before being transported to Paris, where it remains on display to this day at the National Museum of Natural History. By 1799, Adrien Gilles Camper, the son of the naturalist who had called it a whale, had re-examined the evidence and concluded that the skull belonged to a giant lizard, unlike any animal currently alive. In 1808, the French anatomist Georges Cuvier confirmed this identification and used the Maastricht skull as the centerpiece of a groundbreaking argument that species could go extinct entirely, an idea that was genuinely controversial at the time. The formal name, MOSASAURS, was given to the animal in 1822, with the full species name MOSASAURUS hoffmanni following in 1829 in honor of the army surgeon Hoffmann, whose letter writing had drawn scientific attention to the discovery. Appropriately, the limestone beds of Maastricht were found to be so scientifically significant that the final 6 million years of the Cretaceous period were named after them, a term geologists still use today, the Maastrichtian. The Mosasaur dynasty came to an end 66 million years ago, at the same moment that the non-avian dinosaurs, the flying pterosaurs, and a significant portion of all life on Earth were wiped out. An asteroid between 10 and 15 kilometers in diameter struck the shallow sea near what is now the Yucatan Peninsula of Mexico, releasing energy equivalent to billions of nuclear weapons and throwing enormous quantities of debris and aerosols into the upper atmosphere. The resulting cloud blocked sunlight across the entire planet, causing global temperatures to collapse and shutting down photosynthesis on a massive scale. The microscopic algae that formed the base of the ocean food chain died in enormous numbers, and the entire marine ecosystem began to unravel from the bottom up. For an animal sitting at the apex of the food chain, the collapse of the ecosystem below it was fatal. Mosasaurus could not survive without the fish and turtles and marine reptiles it fed on. Those animals could not survive without the smaller creatures they depended on, and those smaller creatures could not survive without the plankton that the blocked sun had wiped out. Mosasaur fossils appear right up to within a few meters of the geological boundary that marks the end of the Cretaceous, found in formations from the Netherlands to Argentina to Antarctica, and then they are simply absent. In geological terms, they disappeared almost instantaneously. A lineage that had taken 30 million years to build one of the most successful and widespread marine dynasties in Earth's history was gone within what amounts to a geological eye blink. After the mosasaurs disappeared, crocodilians temporarily expanded into coastal marine environments and took over some of the ecological roles the mosasaurs had filled. Eventually, tens of millions of years later, the ancestors of modern dolphins and whales would make their own journey from land back to the ocean, following the same evolutionary logic that the Aegialosaurs had followed nearly 100 million years earlier, and filling the ecological positions that the mosasaurs had left empty. The mosasaurs were not an evolutionary footnote. In the 30 million years they dominated the ocean, they diversified into dozens of species, colonized every ocean and sea on the planet, invaded freshwater environments, developed warm-bloodedness, spread to every latitude from the tropics to the poles, and rose from a 1-meter shoreline lizard to a 14-meter ocean apex predator in what amounts to a very short time in geological terms. They represent one of the most dramatic and successful transitions from land to sea that evolution has ever produced, and the fact that their story ended as abruptly as it did serves as a reminder of just how quickly the conditions that allow an animal to thrive can change. Please let us know in the comments what you thought of this video and tell us what you would like to see next. Stay tuned for more videos and thanks for watching.